Derivatives of inverse functions. So we're going to start off with a couple basic examples of inverse functions. And then we're going to try to find a pattern that we can use for all inverse functions. So the first thing we want to talk about is, what is an inverse? So let's recall back from Algebra 2, maybe even Algebra 1. In order to find an inverse, remember the first thing you want to do is switch x and y, right? And then you want to solve. So in order to get y by itself, I'm going to take the square root of both sides. So when I take that, I'm left with y equals the square root of x. And then we have inverse notation, which is really f to the negative 1 of x. So that is going to be my inverse function. So this is my function, and that's my inverse function. So if I were to graph this, well, let's see, the square root of 0 is 0. Let's go up to 4. The square root of 4 is going to be 2, okay? The square root of 9 is going to be 3. So we get this like square root kind of curve here, right? So that's our basic square root function. So let's talk about now what we can determine about the slopes of those two graphs. So if two things were inverse functions, what can we determine here? So if I have f of x equals x squared, let's find the value of f of 4. So if I plug 4 in, I'm going to get 16. So f of 4 is 16, which means I have the point 4 comma 16, right? Now, if you guys remember in inverses, remember I had the point 4, 2, but then remember over here I had the point 2, 4. I had the point, the square root of 1 is 1, so I should have 1, 1, and 1, 1. Oops, 1, 1, that was a little off. 1, 1, and 1, 1, so it should look up like that, right? So remember that when you have, if this is going to be 2, 4, this is going to be 4, 2. So in inverse functions, the x and the y value are flipped because that graph is reflected over the line y equals x, right? So that line makes it completely reflexive right there. So if I wanted to find the value of f prime of 4, so let's actually find out what the derivative of this is. So f prime of x is going to be 2x. So f prime of 4 is going to be 2 times 4. So I know that the slope is going to be 8. So my point is 416, and my slope at 4 is going to be 8. Okay, so that's what I know so far. Now, in my inverse function, I know that if I have the point 416, I know that in the inverse, it should be flipped. So when I plug in 16, I should get 4. So let's just double check. G of 16 is going to be the square root of 16, which is going to be 4. So I have the point 16 comma 4, okay? Now that's not always going to be given to you, so you guys have to make sure that you know that if I tell you that two things are inverses, you know that their ordered pairs are just going to be flip-flopped, okay? Now the new pattern we want to figure out is, what is g prime of 16? Well, let's make sure we know g of x is going to be x to the 1/2. So g prime of x is going to be 1/2 x to the negative 1/2, which is 1 over 2 square root of x. So when I go and I plug, if I apply g prime of 16, that's going to be 1 over 2 times the square root of 16, which is 1 over 2 times 4, which is going to be 1 over 8. So what do we notice about the slopes here at those points? So hopefully we'll see that they're technically reciprocals of each other. So if the slope in my first equation in f of x is 8, then the slope at my inverse in that opposite ordered pair is going to be 1 over 8, okay? Now let's check and just make sure that that's true all of the time, okay? We want to make sure that that's true all the time. So let's try x to the third, okay? And I already did that inverse for you, and we're also going to call the inverse g of x. So I have this function, x to the third plus 1, and then I have this function where they're telling me that it's an inverse, And I have x minus 1 to the 1/3 power. So let's find f of 2. 2 to the 3rd plus 1 is going to be 8 plus 1, which is going to be 9. So I have the point 29. Okay, which I should automatically note it right away. G of 9, I should get 2, right? So we can check if we want. 2 minus 1 to the 1/3. Or sorry, 9, sorry. I was wondering why that was. So that should be 9 minus 1 to the 1/3 is going to be 8 to the 1/3, which is the cube root of 8, which is going to be 2. So that worked. Okay, so I have the 0.29 and I have the 0.92. Well, let's find the derivative here. F prime of x is going to be 3x squared. So if I want f prime of 2, I'm going to have 3 times 2 squared, which is going to be 3 times 4, which is going to be 12. So if that slope is 12, we're going to assume, and our guess is going to be, that if I have the reciprocal point, so 2, 9 is going to become 9, 2. If my slope in f of x was 12, I'm going to guess that this is probably going to be 1 over 12. Okay, but before we go any further, let's just double check. So g prime of x is going to be 1/3 of x minus 1 to the negative 2/3, which is really 1 over 3 times x minus 1 to the 2/3. So g prime of 9 is going to be 1 over 3 times 9 to the 2/3, which is 1 over 3. Now, 9, oh, x minus 1, 9 minus 1, so that's going to be 8. Oopsie. So the cube root of 8 is going to be 2. So cube root of 8 is 2. 2 to the 2nd power is going to be 4. So that's going to equal 1/12, which came out to work. Okay? So no matter what, if you ever have a function and then you have that function's inverse, you know that if I have 2, 9 in one function, then I'm going to have 9, 2 in the other function. If the slope at that point is 12, then the slope at the inverse point is going to be the reciprocal, which is 1 over 12. Okay, so let's just kind of generalize that now, and let's give you a little bit of a formula to work with. So what does this tell us? We know that if g of x is the inverse of the function, then we know that g prime of x, okay, so the slope at the inverse, slope at the inverse point is equal to 1 over f prime, so f prime, so the slope of the original equation. At that y value in g of x, right? So we want to take the y value at that point in g of x, plug it into f, and find the derivative. So this formula is going to be what we are going to kind of carry through as like our rule for when we find the derivatives of any inverse functions. So anytime you see an FRQ and they say something, or a multiple choice question, and they say anything about two functions are inverses of each other, there's a really good chance you're going to be using this rule. Okay? So let's practice it. The function f is defined by f of x equals x to the third plus x squared plus 6x. And we know the point 1, 8 is on the graph of f. So I know the point f of 1 equals 8. And then they're telling me that g of x is the inverse of f. So if I know that g of x is the inverse, I automatically know that g of 8 is going to equal 1. Automatically, that's something that's 100% known here. Okay? I also know that f of x is going to be x to the third plus x squared plus 6. So I want to find g prime of 8. I'm going to use my formula. G prime of 8 is going to be 1 over f prime times g of 8, right? F prime of g of 8, sorry. 1 over f prime of g of 8. So if I want to solve this, the first thing I'm going to figure out is whatever g of 8 is. which I know they don't explicitly tell me that in my table or in my problem, but I do know that over here, I actually already figured that out. I know that g of 8 is equal to 1, right? So now all I need to find is f prime of 1. Now I know f of 1 is 8, but I don't know what f prime of 1 is yet. I'm going to have to do a little bit of work to figure that out. F prime of x is going to be 3x squared plus 2x plus 6. So f prime of 1 is going to be 3 times 1 squared plus 2 times 1 plus 6, which is going to be 6, 7, 8, 9, 10, 11. So it's going to be 1 over 11. Okay? So that formula is very, very important for you guys to recognize and to realize. Now, it might not always be the functions f and g that you're using, but just remember that f is going to be your original function, and g is going to be the inverse function here. Okay? So we got to be careful there. The other way you can do this is you can say, all right, well, f of 1 equals 8, and g of 8 equals 1, and I know f prime of 1 I found was 11, so I know g prime of 8 has to be 1 over 11. Okay? All right, next one, Khan Academy practice. So if I give you guys practice on Khan Academy, this is what these functions will look like. So we have a table of values here. They're giving me f of x, g of x, and f prime of x. They also tell me up here that f and g are inverses of each other. So I know automatically g prime of x equals 1 over f prime g of x. So if I want to find g prime of negative 2, 1 over f prime of g of negative 2. So let's start with the interior of this composition. So what is g of negative 2? G prime of negative 2 is going to be equal to 1 over f prime of, well, g of negative 2 is going to be 5. And then can I use my table? My table tells me that f prime of 5 is going to be negative 1/2. So 1 over negative 1/2 is actually going to come out to be negative 2. Okay. All right, another Khan Academy practice. So f of x and g are inverse functions. We know that f of 2 equals 11, so I know automatically if they're inverses that g of 11 is going to be equal to 2, right? Now, I don't want to know g of 11. I want to know what g prime of 11 is. So if I want g prime of 11, I got to use my formula. 1 over f prime of g of 11, right? So g prime of 11 is going to be 1 over f prime. I know g of 11 is 2 because I already processed that. I already told myself that if f of 2 is 11, that g of 11 had to be 2. Now I got to find out what f prime of 2 is. Now that's not explicitly given to me anywhere, but I have enough information where I can figure that out. So if f of x is x to the third plus 2x minus 1, then I know f prime of x is 3x squared plus 2. So if I want f prime of 2, I'm going to do 3 times 2 squared plus 2, which is 3 times 4, which is going to be 14. So g prime of 11 is going to be 1 over 14. Okay, so anytime you have inverses, you want to write down everything that you know first off, and then go and try and substitute into your little formula that we know. Okay? All right, last practice. Now this one's a little tricky. It's a delta math practice. So the table below gives selected values for the differentiable and decreasing function, f, and its derivative. If f inverse is the inverse of the function, now if you guys want, we're used to using g, so in your own mind, you might want to think of that as g. AP-wise, you don't want to technically rename a function, but we can say f prime of x is going to be equal to g here. What's the value of f prime? The inverse function prime of 4. So this is really going to be g prime of 4. Okay? So they're giving me the table here where I have everything for f of x, but they're not giving me anything for g of x. which is okay because I can go and I can add a table for g of x. Okay, if I know that f of x is negative 1, 6, then I know g of x is 6, negative 1. If I have 4, 2, I know I'm going to have 2, 4. If I have 8, negative 1, I know I'm going to have negative 1, 8. And if I have 10, 4, I know that I'm going to have 4, 10. Okay, that's probably enough for us right now. Let's go and see what the equation tells us. So if I want to find g prime of 4, I have to do 1 over f prime of g of 4. So let's start with the inside, g of 4. So what is g of 4 going to be? Well, let's look here. Oops. Let's look here. G of 4, if I look at my table, I know g of 4 is going to be 10. So now I got to find 1 over f prime of 10. Well, my table also gives me f prime of 10. F prime of 10 is going to give me negative 7. So there you go. Okay? So the big thing here to realize is that if I have the point negative 1, 6 in f of x, then I'm going to have the point 6, negative 1 in g of x. Okay? If I have the point 4, 2, I'm going to have the point 2, 4, and so on. Okay? You have to realize that they're always going to be inverse points are going to be completely flip-flopped ordered pairs, and inverse slopes are going to be reciprocals of each other. Okay, so at the same point in the inverse equation, you're going to have a reciprocal slope. Okay, so in class, what we're going to do is we're going to do a little bit more practice on using these, but coming into class tomorrow, you guys will have to make sure that you have something in your notes regarding that equation, okay? And just remember that the reason why that equation is true is because of these examples that we went through. We discovered that the slopes were going to be reciprocals of each other, okay? So that formula just comes from taking those ideas that we, guess and tested with a little bit there and formalizes it into a formula that will work all of the time.